Okay, today we're going to learn lesson 3.2, and the title of this is Understanding Relations and Functions, and the homework going with this lesson is on pages 102 to 106. We're going to do 2 through 12 all, and then 14 through 22 even. So in this particular lesson, when it says understanding relations and functions, we want to kind of talk about the idea that anytime you kind of pair two sets of numbers together, we can call anything like that a relation. But in order to be considered a function, we have to have a really specific, special kind of relation. So what we want to be able to do at the end of today's lesson is look at some different relations of numbers and decide for sure, are they a function or are they not a function? So we're going to start out with just kind of the definition of what a function is. So I'm going to zoom in just a little bit tighter here. And we're going to take a look right here where it talks about the definition of a function and says that in order to be a function, each value for x will correspond with only one value for y. So when we have a relationship relating x's to y's, as long as each value for x corresponds directly with only one value for y, we have a function. So the first way we want to be able to determine if something is a function is we want to be able to look at a table of x and y values and tell right away if it's a function or not. So we're going to do that by asking ourselves one easy question. I'm going to write down this question. I'm going to write down, does the x repeat? So when we ask ourselves that question, does the x repeat? We're going to make a little chart of our answers here. If we ask that question and we say, oh, no, the x does not repeat, then we have a function. If we ask ourselves the question, does the x repeat, and we say, yes, the x does repeat, then what we're looking at is not a function. So we're going to take a look at all the completed tables on this page for a second, and we're going to run through this question and ask ourselves, do the x's repeat? And we're going to decide if it's a function or not a function. So I'm going to scoot down to this table right here that's already been completed for us. And in this particular table, I know this says x and f of x. When we're looking at functions, sometimes they like to use function notation, and that symbol f of x means the same thing as a y. They're kind of interchangeable. So this is just kind of x coordinates and y coordinates. And when we're wanting to decide, is this a function, we're not concerned about the y coordinates. We just want to look at the x coordinates and say, do any of those x values repeat themselves? And they do not. So this would be considered a function. And then I'm going to go ahead and scoot down to the bottom of the page for a second, and we'll come back to these tables later. But at first, I just want to practice looking at the table and saying, looking across the x row, do any of those x values repeat themselves? No, they do not. So this is a function. But if you look at the next table, things are going to be different. If we look across the row of x values, we're going to see that this 1 is repeated more than one time. This is not a function, because if we think back to the definition we highlighted at the top of the page, this is not a function because this x value is corresponding to two different y values, and our definition said the x value could only correspond with one y value. So this is not a function, and the easy way to tell is if you've got one x being used multiple times, automatically not a function. But if we go back to this table right here, no x values are repeating, this would be considered a function. So we have learned how to look at a table and tell, is it a function or is it not a function? And then what we're going to go ahead and do as well is we talked a little bit about the terms domain and range in lesson 3.1. Just a quick review right here on the page. We say that domain is the set of values for x, and range is the set of values for y. So today in our problems, they're going to ask us not only is this a function, but if it is a function, they want us to be able to give the domain and the range. But they're going to write it a little differently than what we wrote yesterday. They're going to write it in what we call set notation. So they're going to say since the domain is the x values, they're going to say that the domain is the set of numbers with these little squiggly brackets here, containing 1, 2, 3, and 4. And the range is the set of numbers containing 3, 4, and 5. So let me show you the table they're referring to right here. It's this one that was completed right there. And in this table, the x values are 1, 2, 3, 4. Okay, but we're going to notice that in the y values for range, there was 3, 3, 4, and 5. But when they wrote the range, they did not repeat the 3 twice. So the 3 can repeat and it still be a function, but if the definition of range is what are all of the possible y values, then the possible y values are 3, 4, and 5. We don't need to know that there's 2 3s, just the possible values are 3, 4, and 5. So I'm going to make a special little note here as a reminder that when you write these answers for domain and range, you list from least to greatest and don't repeat numbers. So we're going to put that skill to the test right here. These two that we said were functions, we're going to practice writing their domain and range. I usually just use a capital D for domain and a capital R for range. But we're going to practice using your squiggly brackets for set notation, which are a little interesting the first times you try to draw them, but you'll get better at it. Domain is our x values. So that's 0, 1, 2, and 3. Range is our y values, but we do want to list them from least to greatest. So from least to greatest, we would say -3 is the smallest y value, then -2, -1, and 0. So one more time, domain is your set of x values. So in this function, it would be 0, 1, 2, and 3. And your range is your set of y values. So this one would be 1, 2, 3, and 4. Okay, continuing with a few other skills we need on the back side of the paper. We have some problems where we are going to need to recognize in a given situation if we're dealing with a function or not, and give the domain and range in the context of a particular problem. So what we're going to take a look at right now are a couple of problems off of page 100 so that we start to understand how to follow the directions correctly for a few problems on the homework. So these particular problems have a lot of directives up here in bold that tell us what we need to do. And we're going to do most of what they're asking, but one of the requests is a little repetitive, so we're going to skip a little bit of these directives. So they're going to give us a situation, and they would like for us to tell them the domain and range of each relation and interpret them in context. So within the context of the problem they're giving us, they want us to not only list the numbers for domain and range, but kind of interpret or explain what they mean in the setting of this problem. We're going to leave out the part that says state the corresponding outputs for the given inputs in context because it's a little bit repetitive of that first step we're going to do. But we are going to do the final direction that says explain whether the relation is a function because we know how to do that from what we did as examples on the front of the page. So we're going to do those directives on problem number 4 right here. And you're going to see how this is different than just the front page with a plain table because it gives us a table, a graph, and a mapping diagram in the context of an actual numbers, like some real data. So this problem says the relation represents the time spent exercising and the number of calories burned during that time. So it's the same data, they've just showed it to us 3 different ways. Here's a table where we see the minutes and the calories burned. Here's those same 4 data points graphed out on a grid. And then this is what we call a mapping diagram that maps your x and y coordinates to one another. So using this data, again, the first direction at the top of the page said give the domain and range and interpret them in context. So here's kind of the answer style I'm looking for. So when you get to the homework problems that have these directions, you can model your answer exactly like we're about to write down right now. We would say that the domain are those numbers that were in the left-hand column of the table, like the X column. They were 20, 30, 35, and 60. But we're just going to add on the extra step where they said interpret them in the context of the problem. So if you recall in the table, those numbers in that left-hand column of the table were showing us the minutes of exercise. So that's us interpreting the domain. Range, on the other hand, okay, there were 4 numbers in the column, but the middle number repeated itself. It said 50, 85, 85, and 100. We do not write the 85 twice. There were only 3 possible output numbers. That's all we write. And we say what those represented was calories burned. And then the final part of the directive that we're going to finish is it asked us to explain whether this relation is a function. So we go back to what we learned on the front side and we ask ourselves, do our x values or our domain numbers repeat themselves anywhere? And our answer would be no, they do not repeat. So therefore, this is a function. And they wanted us to explain that. So I would just say because no x value repeats. And then if you were to come across a problem in the homework that was not a function, you would just write not a function, and you can explain yourself by saying because there is an x value that repeats. So we don't have to get overly creative with this description, just knowing your rule of it's a function if no x values repeat. It is not a function if you have x's that repeat. You should be completely fine. So I think there's about 6 problems in the middle of the homework that look exactly like this one. So this is kind of your format to follow. Okay? So all of those rules we've discussed so far are super great for telling if the numbers in a table are a function or not a function. However, we also need to be able to look at a graph and quickly tell if it's a function or not. So we need to discuss something called the vertical line test, which was a little bit familiar to people from last year, so that's a good thing. I'm going to write down a quick definition that says a relation is a function if a vertical line would only pass through its graph at one point at a time. So to illustrate this, we're going to take a look at a couple of the drawings that were already graphed out on page 101 of the textbook. So if you want to look at page 101, you're going to see graphs 6 and 7 down at the bottom of the page that look like this. And we need to be able to look at those and just by visually testing them with our eyes, decide if they're a function or not a function. So I'm going to kind of draw a miniature rough version of those on my notes so that we have those for future reference. This is kind of what number 6 looked like. And this is what number 7 looked like. And we're going to look at the difference of what happens with them in the vertical line test. I always kind of like to pretend the vertical line test is kind of like I take my vertical line, okay, and I can use your pen, your pencil, your pinky finger, whatever it may be. And if you were to start with a vertical line on the left side of this graph and scan it all the way across, to pass the vertical line test, you have to be able to make it all the way across the graph without ever hitting the graph in more than one point at a time. So if I were to scan a vertical line through this, I would say it passes the vertical line test, because at any given moment, if I have a vertical line going through right here, it only hits in one spot. If I draw a vertical line right here, it only hits in one spot at a time. So I would say this is a function that passes the vertical line test, But in contrast to that, number 7 is not going to work out the same way. If I try to scan my vertical line from left to right across this graph, I instantly run into a problem. I'm going to draw a little dotted vertical line through here. I'm going to put 2 big X's right here. Because right here, I am hitting the graph in 2 very clear places with my vertical line at the same time. So this failed the vertical line test. This is not a function. All right, one final skill we need to be able to do, because it happens to be just like the very first homework problem in this lesson, is I want to do one example where we show how to make a table, graph, and mapping diagram given some information. Okay? So in the problems that require you to make these 3 representations, what you're going to be given is a large set of ordered pairs. So here's one that I made up just for an example. My first ordered pair is 510. Then I have 620. Then I have 623 and 735. So I've been given this set of data and I've been asked to make 3 different representations. The table is by far the easiest. You have a big list of ordered pairs, which are just X and Y coordinates, that you're going to make an X and Y column, and you're just going to fill in your ordered pairs. So tables should be no problem. Okay. As far as graphs go, we're going to make an X and Y axis here. Okay, and because my X coordinates are pretty small, like 5, 6, and 7, I can probably count by ones down here. I don't need to make a super large graph going out in this direction. But since my Y coordinates are like 10, 20, 23, 35, in order to get all the way up to 35, I'm going to choose to count by 5s here and do 5, 10, 15, 20, 25, 30, and 35. And so don't expect that these points are always going to line up. We're not graphing lines at this point. We're just graphing points of data. So these are going to be a little scattered across the grid here. We got 5, 10, we have 620, and for 623, that's going to kind of have to float between my lines for 20 and 25, and then we have 735. So I know this question didn't ask it, but you should be able to tell from what we learned. See how the X repeats itself, and these stacked on top of each other would not pass the vertical line test? This is not a function. It's a relation, but it is not a function. And then let me show you how to do a mapping diagram. For a mapping diagram, you're either going to make 2 side-by-side rectangles or 2 side-by-side ovals. And you basically put your X coordinates in the left rectangle and your Y coordinates in the right one. But you want them to go in order from least to greatest and don't repeat yourself, kind of like domains and ranges. So for the X values, I'm only going to put 5, 6, 7. I'm not going to put 5, 6, 6, 7. And my Y values are 10, 20, 23, and 35. And it's called a mapping diagram because you map which input goes to which output. The 5 goes with the 10, the 6 goes with the 20, and the 23. Again, that's why this is not a function, because this X value is paired with 2 Y values, and 7 goes with 35. So, hopefully we understand the difference between relations and functions. To tell if a function or if a relation is a function, if you're looking at a table, you ask the question, does the X repeat or not? And to tell from a graph, you do the vertical line